Hello, everyone, and welcome back. Before we get started, somebody asked me a question. I thought it was a really good question, something that I don't think I quite explained. It's the meaning of the word attribute. I thought, what a great question to ask. So another word for attribute is characteristic, and what that means is it's just things that a shape has. So I can count the number of sides, and the number of sides would be an attribute or a characteristic. When I describe how big the angles are, if they're right angles or smaller than a right angle or bigger than a right angle, that can be an attribute. Parallel lines, all those terms that we talked about the other day, those are all characteristics or attributes of that shape. So today we're going to be looking at some more shapes. We looked at quadrilaterals yesterday, which are shapes that have four sides. That was one of their attributes or characteristics. We're going to go ahead and look at more today. Let me go ahead and pull up the lesson. Module 7, Lesson 5. Our learning target is to be able to compare and classify other polygons. Now, I didn't want to do a lot of extra fluff today. I kind of want to just jump into it so I could spend more time talking about these shapes and some things that we might notice with it. Again, when we're comparing, we're looking at more than one and seeing how are they similar, how are they different. Classifying is putting them into groups that they have common attributes or characteristics with. And then a polygon is a closed shape that has many sides. Yeah, it means many sides. Here's our shapes that we're working with today. Now, they're a little bit different than our shapes from yesterday. Yesterday, every single shape had four sides. These shapes are not limited to just four sides. In fact, this very first one, M, looks like it has 1, 2, 3, 4, 5, 6, 7, 8 sides. And as we're looking at them, some of them look nice and neat, and some of them look crazy. Like, what is going on, O? You're looking crazy today. Same thing with you, Z. So let's go ahead and look at these. And some of them we might be able to give names to because there's a pattern with prefixes and kind of that root word of gone. So for example, on M, we just counted it has 8 sides. The root word for 8 is octo, and like octopus. So an octagon has 8 sides. Now, we're going to be looking at some of these attributes that these shapes have, and we'll talk about the shapes as we go through them. In this one, we're looking for if all the sides are equal or the same length. And if I look at M, I'm going to be eyeballing this. I'm just going to be doing my best guess. They're not trying to trick us, but there's some things that we should look at. So it looks like these lines are parallel. And if they are the same length, they'll stop and start at the same spot. It looks like they are all the same length. So I'm going to go ahead and move this shape in here. And for all of these shapes, either all of the sides are equal or they are not. So they're either going to be up here or down here. If I look at this one, the opposite sides are the same lengths, but it doesn't ask if the opposite sides are the same length or equal. It says all sides are equal. These lines are much longer than these ones. So this one is going to go down here. This is a rectangle, by the way. Now we get to O. What shape is this? I'm going to start right here on this point. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 sides. The root word for 10 is deci, like decimal or decimeter. We use that in all kinds of different root words. So this is a decagon, I believe. And I can tell you right now, this line is really long and this line is really short. So for that one, it's going to go down here. Not all the sides are equal. This one, it looks pretty much all spread out. Now, I want you to notice something about shapes M and P and possibly some other ones. We can count the number of sides. 1, 2, well, we'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides. All of the side lengths are equal, and it looks like all of the angles are equal. So they're all spread out nicely. We call that a regular polygon. And in this case, I wish I remembered off the top of my head what the root word for 12 was. But this is a regular decagon, and we'll look for some more regular shapes later. It just means that all the sides are the same length and all the angles are the same. Let's look at Q. Are all the sides equal? Well, this side looks a lot longer than this side, so I'm going to say no, not all sides are equal. We're going to put it down here. With this one, this is a parallelogram. We talked about it yesterday a little bit. It is a quadrilateral, and it looks like these two lines are parallel, but they're not the same length because these kind of angle outwards. So we're going to put this shape down here. This one, and although it's tilted on its side, it actually looks like a square. There's 4 sides that look like they're all equal, and there's right angles for all of the angles. And so a regular quadrilateral we would just call a square. For T, it's looking like there's some right angles right here. And so these lines will be perpendicular, and then it cuts in on both sides. And it looks like this length is much shorter than this one over here. Plus, I don't think all of these sides are the same length, so I'm pretty sure this one's going to go down here. U, it looks like it's regular. It looks like all the sides are the same length and all the angles are the same angle. Let's count how many sides there are. 1, 2, 3, 4, 5, 6. So a closed shape with 6 sides is a hexagon. Hex means 6. And this is a regular hexagon because all of the side lengths look to be the same and all of the angles look to be the same. Let's look at V. 1, 2, 3, 4, 5 sides. So this is a pentagon, but not all the angles are the same. And look, this side is short. These sides are longer, so not all sides are the same. So it's not regular. So we're going to go ahead and put this down here. Now we have a triangle. Tri means 3. So you got 3 sides. It looks like all of them are the same length and all the angles too. So we're going to put that over here. And our last one, what shape is this? 1, 2, 3, 4, 5, 6, 7, 8. Ooh, this is also an octagon. It looks nothing like its twin or its brother, M or sister or however you want to call it. They have the same name, but this one, all of the side lengths are equal and all the angles are equal. This one is not, so we're going to put it down here. Now, that's interesting. All of these shapes up here where all of the sides are equal, it also looks like all of the angles are equal. And so they're all regular polygons. And it's not to say like, well, these, that term regular isn't used in the normal sense of the word regular. When we're talking about shapes, regular just means that all of the sides are equal and all the angles are equal. So when I say this is a regular octagon, that's exactly what it's describing. I actually have a tool up here, and if you see, when I highlight it, it says regular polygons. And when I use this tool to draw a shape, it'll make sure that all of the angles and all of the sides are the same length and draw those shapes. I can't do anything to squish it. If I wanted to squish it, I'd have to use a different tool. Just whipping all these different shapes out. It's a nonagon. Decagon. I don't know 11 or 12 they're called. But that'd be really hard to draw. And they start to get more and more circular, which is kind of interesting. Now, if I use this tool and draw a shape, let's see. We got some more shapes in here. And I draw, for example, a pentagon. That's a regular pentagon. This one, I can change the shape of it so it's not a regular polygon. These lines are longer than these other ones. All right. It's kind of fun to explore shapes. Just look at them. Now here I'm looking for shapes that have at least one right angle. So I'm going to make a square. Let's actually make sure that it is a square and use our regular polygon. And we're going to use this as a tool. Normally you could use like a piece of paper or a sticky note or a book. We have lots of right angles all around us. The corner of your house is usually a right angle. Sometimes I have some corners that are not quite right angles, but a lot of times we use right angles, so you're used to seeing them. We're going to use this as a tool to check right angles. I don't see any side on this shape that looks like it's a right angle, and I clicked on, okay. I can rotate this to try to help me check. Let me rotate it a little more. And yeah, it doesn't look like there's any angle on here that matches up with this. So this one, it's not going to go in there. Now let's look at N. This looks like it might. Let's try lining it up. Yeah, that matches up quite nicely. So this has a right angle. Does O have a right angle? Now we might look at that initially and say there's no way that has a right angle. But there's some that are close. We might actually need to check. Like let's look at this one right here. Twist that. Yeah, it's not quite. Okay, let's try this one over here. It looks like that one's not going to match up. That one doesn't match up. What about over here? It takes a little bit of time, but I got to check to make sure that none of these are right angles. Yeah, that one doesn't quite line up. So this one's looking like a no, but I did have to check because some of them looked like, you know, I have one right here, so maybe you're thinking, no, Mr. Sarah, none of those looked close. Now look at this one. Now, one of the interesting things is sometimes you might notice some patterns. Like, for example, with regular polygons, since all of the angles have to be equal, because all the side lengths are equal, if one of these angles doesn't match up to 90 degrees, then none of them are, because they're all equal to each other. And I find that's the interesting thing about geometry, is that a lot of times there's some interesting patterns, and later on you'll call them proofs, talking about shapes. Let's look at Q. Q looks like it might actually have one. These two, they look too small. Let's look at this one. I gotta get this lined up. I can't get my tool quite lined up, but it looks, oh yeah, look at that. That looks like it's 90 degrees. So let's go ahead and add this one to our list, 90 degrees. Try this one down here. Trapezoids are always a little tricky. Now let's move this up. And doesn't look like it's gonna work. Doesn't look like either of those are 90 degrees. Let me check this other side. Yeah, they're not quite lining up. So this one's a no. Now this one's up here. What do you think? It's a square, and I'm using a square to check. I think that it has at least one right angle. So let's go ahead and take a look. Oh, and if I can get my tools the correct direction. There we go. Yep, that's definitely gonna do it. So at least one of them is. Now this one, it doesn't not all of them are right angles, but that's okay. We just need to find one. So let's go ahead and check one that we think might be a right angle. And that's looking like those lines are matching up. So this one has at least one right angle. We already figured out with regular polygons that if one doesn't work, then none of them are going to work. And so none of those work. V, There's a couple that look close. Let's check. Yeah, that's not quite there. Just a little bit underneath it. This one over here looks like it's a little too big, so that's a no. Well, this one is a no. This one looks like it has a couple. Wait a minute. Is that one right there? Z has one right there. You see that? Wow, at least one. So that's a crazy looking shape, but it has at least one right angle, and that was the attribute or characteristic that we were looking for, and we found it. So normally you can use like a sticky note or something. I've got two sticky notes. A sticky note, and you can say, well, let me see, does this book I have over here have a right angle? And we can check it. Yeah, that has a right angle. I don't know. Does my ear have a right angle? Yeah, it's going to be a no. Doesn't match up quite right. So let's go look at our last attribute for today. We're looking for at least one set of parallel lines. Now this one we're just going to try to eyeball. We want to remember, what is a parallel line? It means that the opposite sides from each other, they would continue going forever without touching. If we just drew lines forever and ever, we're looking for at least one set. So if I look here at M and the opposite side, it looks like those might just be parallel. So I'm going to go ahead and say yes, this has at least one set of parallel lines. In actuality, a regular octagon has 1, 2, 3, 4 sets of parallel lines. This one as well, it looks like the opposite sides are parallel. They'll never touch. This shape is crazy. It's got a lot going on. So it's going to be really hard to tell. And I'm going to look at lines that look like they might be parallel and try to decide if they ever would. And I could use a tool like a pen or something to draw and check to see. But I'm just estimating right now. So if I continued this line forever and ever and ever, is there another line? Would this line right here ever touch it? And it looks like if I continue it forever and ever and ever, that these are getting farther apart. See, look, it's kind of a shorter line and it's kind of longer as we go. And since these sides are getting further away, that means that these sides are getting closer together. So those ones are not parallel. Erase those. Let's see, what about this line? This line doesn't, yeah, oh wait, let's look. This line right here, and this line right here. Well, it's close, but it looks like they're getting closer and closer together because my line's not perfect. That was a really bad line. My line's not perfect. That one's really hard to tell. Since it's hard to tell, I'm going to go play on the safe side and say that it doesn't. This one, it looks like it does. The opposite sides look like they never touch each other. So I'm going to go ahead and add that one. This one, they're already intersecting, so there's no way on that triangle. This one, shape R, it looks like these opposite sides right here, oh my goodness, I cannot draw a line today. Never going to touch. They don't look like they're getting closer together or further apart. And so we're going to go ahead and add that one. That's at least one set of parallel lines. Squares, that looks like it has two sets of parallel lines. So we'll go ahead and add that one. We're just looking for one set of parallel lines. So let's look at the top line and the bottom line. What do you think? I'm thinking those would never touch if we kept drawing them forever and ever. So I'm going to go ahead and add that. I'm going to say this has one set of parallel lines at least. This hexagon, it looks like it might have multiple sets of parallel lines. If I kept drawing this line forever, and this line forever, they're never going to touch. Same for this line and this line, and for this line and this line. Pretty cool. And add this. This shape, when I first look at it, it doesn't look like it has any parallel lines, but I might try to check anyway. Nothing's running parallel to this. Those two lines are definitely getting closer together. Yeah, there's no lines. Same for this. Now Z. What a strange shape Z has been for us today. We're going to go ahead and try to check Z. And let's say this line looks like it might be parallel to this line. Man, bad lines. to practice my line drawing or find a tool that'll draw lines for me. Now, my drawing looks like they're getting closer together, but I honestly think it's just my drawing. I think if I was a perfect artist and I could draw a perfect line, those don't look much like they're getting closer and closer together. I'm going to go ahead and say yes on that one. I'm going to say that that has at least one set of parallel lines. Because they certainly can be, even though it's a wacky looking shape. Today you're going to be looking at the attributes of polygons. They're not just going to be quadrilaterals, and we're just going to be classifying them. It's what we just did together. Okay? So when you look at a shape, think about the shape. What traits, qualities, characteristics, whatever term you want to use, do they have in common with each other? How are they different from each other? And that's what we're doing for our lesson today. It is Friday. I hope you guys have a great weekend. I will see you again on Monday. Until then, stay safe, find some opportunities to do some math, and have some fun.